7.3. This next video is going to be on sine and tangent, the sum and difference identities of those. And so sine, we're going with the story, the love story, which on Cosette's part is not really a love story, but on Sinbad's part it is. So we have Sinbad. So Sinbad, sine. So Sinbad arranges the date. So Sinbad, and it's a double date, right? So here we have double. So Sinbad hangs out with Cosette, and then he makes his brother. So he makes his brother, so I always say his brother, so I change the letter. So sine of A minus sine of B, so you change the letter because I can't put sine of A because that would be himself again. But Sinbad's brother hangs out with Cosette's sister, so you have to change the letter here. So what you'll see in the book is you'll see something like this. It's usually written like this. And that's where I messed up here. And their signs are actually the same. And so this one would be usually cosine of A and sine of B. So that's what you usually see in the book. And I do this, even though I messed up here. This is a plus sign. But here, I did mess up here. I need to put a B here. And then this would be an A. So Sinbad and Cosette. So sine of A times cosine of B plus, because Sinbad says their signs are the same because they're destined for each other. So you keep the signs of the same on sine. And then his brother, so that's when you have to switch the letter, is hanging out with his sister, cosine of A. So what you notice in the book is a little bit different right here. In the book, they put cosine first after the plus sign or minus sign, which is fine. It doesn't matter, because this is multiplication. Sine of B times sine of A is the same thing as cosine of A times sine of B. So really it doesn't matter. But we just need to make sure that the first one, the first term, you have sine of A, cosine of B, and then it switches sine of B, cosine of A. Okay, so make sure the first term has both measures in there, and sine goes with the first measure, cosine goes with the second measure, and then you got to switch those. Cosine needs to go with the first measure, and then sine needs to go with the second one. Okay, and then there should be a parenthesis there. Then the negative subtraction, the difference, would be sine of A cosine of B minus, because their signs are the same, forgot my parenthesis again, and then sine of B cosine of A. So there you go. So there's the story of Sinbad. That's how he arranges the date. Tangent doesn't have a story for it. So tangent of the sum of two measures is tan of A plus the tan of B divided by 1 minus, that's where the sign switches, tan of A times tan of B. And then the negative is just the difference. B is tan of A minus tan of B, and then divided by 1 plus, so I changed the sign there. Tan of A times tan of B. Okay, so those are the sine and tangent sum of difference formulas. So let's go ahead and practice a couple examples. So here we're doing sine 45, so we're asking ourselves what two angles of that we know, right? 0, 30, 45, 60, and 90. And it would keep on going, right? You could do 120 and 135, 150, 180, and so far all the way around the unit circle. But 75 is 45, because we don't know 40, but we do know 45. 45 plus 30, because that equals 75. And then we're going to take Sinbad arranged the date, sine of 45, he goes with Cosette, 30, and then our signs are the same, plus sine of the different angle, because I already did 45, so that means I have to do sine of 30. And then cosine of 45. So what you notice there is you have sine of 45 and cosine of 45, right? You just have that coordinate, which 45 is root 2 over 2 for both cosine and sine. But sine and cosine of 30, sine of 30, so 30 is a lower angle, right, on the unit circle. 30 is like right here. So this distance is longer than the height, right? And root 3 over 2 is longer. And along the x-axis is your x. That goes with cosine, so this is root 3 over 2. And this is 1/2. Alright, so then we multiply those fractions, and then we add those two terms together. So we get root 6. Notice that all these answers are looking the same. Root 6 plus root 2 over 4. Combine like terms. Root 6 plus root 2. Remember, we can't combine those because those are two different. They're the same type of roots, but the underneath is not the same, so we can't add them. All over 4. So you notice that looked like. So that was equal to sine of 75. Well, that was exactly like cosine of 15. Why? Because cosine of 15 and cosine of 75 are coterminals, right? Because 15 plus 75 is 90. One's cosine, one's sine. Coterminals. Okay. Okay. So now I'll do this one tangent. So again, here is a radian, right? Because we have no degree symbol, so we could switch this to a degrees by multiplying by 180 over pi. So then the pi's would cancel out. 12 and 18 goes down to 15. 7 times 15 is 105. So the tangent of 105. So if we look at tangent of 105, and you could have separated this into two fractions over 12 that added together or subtracted together. Usually you're probably going to do addition. You could still do subtraction. But here, I'm going to add to 7. So what two numbers add to 7? So that'd be 4 and 3, because then these reduce down to pi thirds, which we know, right? That's a 60-degree angle. And pi fourths, which is a 45. So 60 plus 45 is 105. So you could do either of these methods. This is probably the one that you're going to do the most, almost all the time. So tangent of 105, we can rewrite as tangent of 60 plus 45. There's different ways that you can do that as well, right? You could do 120, well, not 120, 135, 135 minus 30, because 135 is a 45-degree angle, so you go off of that. But we'll go 60 and 45. So this is tan of 60 plus, because we keep the sign the same on the top, tan of 45 divided by 1, switch the sign now, minus tan of 60 times, so on the bottom here it's multiplication, times tan of 45. So we need to find tan of 60, which is pi thirds, so that means it's just plain root 3. Tan of 45 is nice because it's just 1. And then we just take 1 minus root 3 times 1. So then we have tan of 105 is equal to root 3 plus 1 over 1 minus root 3 times 1 is negative, or negative root 3 times 1 is a negative root 3. Crappy thing about tangent is when we have problems like this, we have a radical on bottom, so we're going to have to rationalize it. We're going to have to multiply top and bottom by the conjugate of the denominator. So that means we're going to have to FOIL. So this goes back to last semester algebra. Rationalize the denominator. So we're going to have to FOIL the top. Root 3, 9, square root of 9, which is 3. 1 times 1, 1 times root 3. So we get root 3 plus root 3. Now here we can actually add root 3 plus root 3 is 2 roots of 3, and 3 plus 1 is 4. And then on bottom they're conjugates, which is nice because 1 times root 3 is a positive root 3, and negative root 3 times 1 is a negative root 3, so the middle cancel out, so all I have to do is first times first, which is 1, and last times last, which is a negative root 9, which is a negative 3. So that's 2 root 3 plus 4 over negative 2. Now remember, I can't cancel anything out with this root 3 on the bottom, say if that was a 6, it was 2 root 6, I couldn't cancel that 6 with the negative 2, because that square root underneath there, whatever underneath that square root symbol, can only be canceled out if something also is underneath the square root symbol. Okay, so we can simplify this by factoring a 2 out of the top. And now that this multiplication, now that we have multiplication here, now we can cancel these 2's. So originally you just can't cancel those 2's because I also would have to take it out of the 4, right? So, but if I factor a 2 out of the top, or notice that, hey, these all have 2's in it, so I can take out a 2, and then I can cancel. So then I get, come on, next, I get this, oops, 3 over negative 1, so that negative 1 would go both to the square root of 3, but on the outside, and to the 2, like that. So tangent of 105 is equal to, or tangent of 7 pi 12ths is equal to negative root 3 minus 2. Okay, so there's our answer for that. Here's another one. Here we're going backwards. So first we want to see, okay, who's arranging the date? Coset, which when coset arranges the date, right, cosine, they both are cosine the first term. But here we have sine coming first, so that means we're going to have, this is going to be sine of a plus b. And a plus b are my two, well, don't put plus yet, sorry, of my two angles. So my two angles are 40 and 160. Okay. Now whichever angle comes first, that's your A. Whichever angle comes second, that's your B. Okay. And now, what does Sinbad say about their sines? Well, he says their sines are the same, so that's subtraction, so that's subtraction. So I can take 40 minus 60, which is negative 120. And what is sine of negative 120? Well, that's over here, down. So this is negative 90, this is negative 180. We're right about here. That's a alpha 60 degree angle, right? So sine down here is going to be negative, so our answer is going to be negative. And we know that because we also know this is an odd function, right? Is negative sine of just the positive angle, right? So we know we're going to have a negative answer. And so we're down here at negative 120. And so it's alpha 60. Because if we take 120 and we add 60, we get to 180. So a 60 degree angle of sine is root 3 over 2. And since we're in the third quadrant, quadrant 3, sine is negative, so it's going to be negative. Okay. So there's our answer for that. Okay, so on page 655. Yeah, 655, number 43, 51, and 57. So you can do these on your own, and then you come back if you need help. For sine, find sine of 15. So 15 is just 45 minus 30. That's one way to do it. So sine, Sinbad arranged date. He goes with coset. And he thinks their sines are the same. And then he takes his brother and makes him go with her sister. So sine of 45 is root 2 over 2, and so is cosine of 45. Sine of 30 is 1/2 though, so that makes cosine of 30 root 3 over 2. And then sines are the same, we multiply those. Remember, when you take sine of 45, you're done with sine. Don't write sine here, sine of root 2 over 2, no. Because that would mean you're taking sine of the angle root 2 over 2, which you're not. Okay, so this is root 6 over 4, subtract root 2 over 4, got a common denominator, so we can go root 6 minus root 2 over 4, and there's our answer of sine of 15 degrees. Okay, number, what do we got now, 51, 57. So looking at tan of pi 12, so pi 12ths. Here you probably want to convert this, multiply it by 180 over pi. So then the pi's will cancel out, 12 reduced down to 15, so we find a tangent of 15. You could have separated into two, But this time you're just definitely going to have to subtract. Oops, why did I put pi on bottom? 12. This time you would have to subtract, because I can't add to get to 1 unless it's 0 and 1. So that wouldn't help me. So what minus what equals 1? So that would be 5 and a 4, but we don't know 5 pi 12ths. So I need something I know. How about 4? Because 4 will reduce that down to pi thirds. And this would be 3 reduced down to pi fourths. So you could do that, but I'm pretty sure most of us are probably going to change it to just degrees. So, but you could use this, because then you know you're going off a 60-degree angle and you're going off a 45, so you know it's going to be 1645. So tan of 15 is the same thing as tan degrees, right? Of 60 minus 45. Okay, so tangent is tan of 60. Always keep the sign the same on top. So subtract tan of 45. And then 1, switch the sign now. So plus tan of 60 times by tan of 45. So you can use your chart, you can use your left-hand method. So tan of 60 is a pi thirds. So that means you're going to have 1 root 3. So just root 3. And then tan of 45 is 1. And then on bottom, we have tan of 60, which is root 3, times tan of 45, which is 1. So then we have root 3 minus 1 over 1 plus root 3. Now we're going to have to rationalize. So do the conjugate of the denominator. Remember, anytime you can stop these videos, try it yourself, and then come back and watch them. Distribute. So we get root 3 minus square root of 9, which is 3, so minus 3. 1 times negative 1 is negative 1. And positive root 3, so that makes 2 roots of 3, and then minus 4. So it's kind of like our other answer. See how we have a negative on the second term there, and then all over the conjugate. The conjugates are multiply each other. So we just take first times first and last times last, so we get a 1 minus 3. So that would be a negative 2. So we have 2 root 3 minus 4 over negative 2. Factor out a 2, because we have a common 2. So I'll go ahead and factor it out so you can see. Or you could write it as 2 different ones, like this. As a, you could do this, sorry. You can keep the negative. You'd subtract 4 over negative 2. So here this would be negative root 3, and this would be positive 2, because a negative and negative equal positive. So this is tan of 15 degrees. Kind of looks like 150, but it's 15 degrees. Equals negative root 3 plus 2. Okay, so now number 57. Back to blue. So sine of 76. So since I'm starting with sine, then you know it's going to be sines, Sinbad's arranged in the date. So 76 degrees, 30 degrees. And then we're subtraction, so you know he keeps their sign the same, so we know it's a negative. 76 minus 31. 76 degrees. So we don't even really need what's next. But it's cosine of 76 and sine of 31. So in the book and on the formulas, usually they keep the first part is 76, so the first part of the second term is also 76. Where I put this, I would do sine of 31 and then cosine of 76. But really, since multiplication doesn't matter the order there. Okay, so then I can subtract these, and that would be 75. 75 minus 30 is 45, so sine of 45, that's what we're really finding here. And sine of 45 is root 2 over 2. So our answer to this big problem is root 2 over 2. So there you go.